Hello viewers, welcome to Google the TV live on Google actually, like I've said, e-learning project sponsored by Trinity SS Naweru. This is Obonyo Kenneth once again. I'm back. I know very many of you have been missing me. I was also missing you. I know everyone is now having a fully loaded Yaka meter readily waiting for the work for today. Due to public demand, today's topic is a Section B topic. It is really going to help us so much. I've had very many messages from very many of you from different schools that requested for that topic. And what we are going to do is exactly to do with quadratic graphs. So without wasting time, what are quadratic graphs? What are quadratic equations? Previously, I told you what quadratic equations are. But those that have just joined us today, let us get to know this. The spelling of the word is this: quadratic equations. Quadratic equations, these are the types of equations whose highest power is equivalent to 2. Highest power is equivalent to 2. Highest power is 2. Still, under quadratic equations, we need to know that these are the types of equations which are written in the form ax squared plus bx plus c equaling to 0. Ax squared plus bx plus c equaling to 0. And much as it is equivalent to 0, we also need to know that where a is never equals to 0. Because the moment a is 0, then it means that you'll have 0 times x squared, which will kill that. We end up remaining with bx plus c equaling to 0, which now becomes a linear equation. But we are not looking at linear equations today. We are looking at quadratic equations. We are still defining what are quadratic equations before we come to quadratic graphs. Now, Mr. Examiner still, we need to know that quadratic equations, the word quadratic originated from the word quadratus. Quadratus, which is a Latin word. Remember Latin, this is the language spoken in Italy, current day Italy. Now, if that is the language, Latin, for them they called it quadratus. But what does quadratus mean? Quadratus in Latin simply means to square. It simply means to square. Now, when this was pushed to the English language, to the English dictionary, instead of calling it quadratus, they called it quadratic. That's why we have it as quadratic equations. We also need to know, Mr. Examiner, sir, that after writing ax squared plus bx plus c equaling to 0, where a is not equal to 0, we need to know that a is known as the quadratic coefficient. Quadratic coefficient. While b is known as the linear coefficient. Linear coefficient. And while c is known as the product, or you can call it the constant. So we are still defining what is a quadratic equation. A is the quadratic coefficient. B is the linear coefficient. C is what we call the product, or you can call it the constant. Have we clearly understood what a quadratic equation is? Now, before we forget, we also need to know that a quadratic equation has different methods of solving it. Method number 1 is what we call the factorization method. The factorization method. Method number 2 is what we call completing square method, or you can just say completing squares. That is the second method that is used to solve quadratic equations. Then again, Mr. Examiner, sir, we also need to know that we have another method known as solution by the formula, or you can call it the quadratic formula. What most of you call the bulldozer method. Then we have method number 4 is what we call the graphical method. Graphical formula or graphical method by the use of a graph. Mr. Examiner, sir, our interest today is not to use the factorization method. Our interest today is not to use the completing square method. Our interest today is not to use the quadratic formula or the bulldozer method. Mr. Examiner, this is Obonyo Kenneth reminding you that our interest today is to use what we call the graphical method. This is the topic that most students out there requested to be helped in, and that is why I'm here today. When we look at the graphical approach, let us go to the graphical approach. Graphical approach or graphical method. First of all, Mr. Examiner, sir, what we need to know is this. Under the graphical method, it is the fourth method that is used to solve quadratic equations. But there are a few things that we need to know when we are using this method here. What are some of those things that we need to know? One, we need to know that this is a method where we use a graph paper. We use a graph paper in the graphical approach. All of you know what a graph paper is. We are going to see how a graph paper looks like. Without a graph paper, you cannot be able to use the graphical approach. And then, Mr. Examiner, sir, we also need to know that in the graphical approach, we also need what we call a table of results. Or you can call it a table of values. You cannot have the graphical approach without having a table of results, because all the coordinates that you're supposed to plot on the graph paper, you have to get them from the table of results. Now, viewers, we also need to go ahead and get to know that in the graphical approach, we don't need to forget the scale. We need what we call the scale. The scale can either be the vertical scale or it can be the horizontal scale. But again, what we need to know is whatever scale that we choose, it must be a suitable scale. It must be a scale that makes us at least occupy 75% of the graph paper. We need what we call paper balance. So we shall have a scale that would make our graph occupy 75% of the graph paper, or we can say 3/4 of the graph paper. Mr. Examiner, still under the graphical approach, we need to know that our graph must have a title or a heading. For example, you can say a graph of the function y is equal to x squared plus 5x plus 6, where x starts from -1 up to +6, and then you underline it very well. The table of results must have what we call the title, and even the graph itself must have what we call the what? The title. Mr. Examiner, sir, what else do we need when we are using the graphical approach? Mr. Examiner, sir, we need also to know that when using the graphical approach, we need to get to know that whenever our coefficient is a positive, for example, if you have x squared plus 5x plus 6, whenever this coefficient here, the first number here of x squared, whenever it is a positive, then simply know that our curve is going to be U-shaped. The moment our coefficient is going to be -x squared plus 5x plus 6, whatever equation it may be. But when the first number here is a negative, then you know that the graph is going to be upside down, like that. So this one is U-shaped like a bowl, or a bucket, or a basin, and then that is when it is a positive here. But when it is a negative, it is upside down. Mr. Examiner, sir, we also need to know that in the graphical approach, we can construct a graph. We can draw a quadratic graph. But we must know that a graph must have what we call a turning point. A turning point on a graph is that point where a curve negotiates the corner. It must be a smooth negotiation. For example, this lower point here is what we call the turning point. It is what we call the turning point of that graph, or that point there where the curve changes direction. It is coming like this, it reaches there, and then it changes direction, moves up again. That point is what we call the turning point. Mr. Examiner, sir, those are some of the hints. Those are some of the items that we need to know when we are attacking our graphical method. These are some of the very important issues to look at before any graph is drawn. But again, before I forget, Mr. Examiner, I must know that in the graphical approach, I must draw the graph after joining the corresponding coordinates. I must use a free hand. I must use a free hand. We do not use a ruler when we're joining these points. We have to use what we call a free hand. And it must be a smooth curve. It must be smooth. We're still on quadratic graphs. We have had the introduction. We have gotten to know what a graph is supposed to look like. Now we have a typical UNEB question here that the examiner wants us to solve. What is the question saying? It says, draw the graph of the function y is equal to 2x minus 1 in brackets times x plus 3 for negative 5 is less than x, less or equal to a positive 1. Part B says, use your graph to solve the equations 1, 2x squared plus 5x minus 6 equaling to 0, and part 2, x squared plus 5 out of 2x minus 3 equaling to 0. Now the examiner wants us to draw our graph. He wants us to use the graph to solve those equations. But like I told you, there isn't any graph that you can draw minus starting with a table of results. So my Mr. Examiner, sir, let us go direct and first draw what we call a table of results. We shall say a table of results for our equation, which is y is equal to 2x minus 1 x plus 3 for negative 5 is less than x, less or equal to a positive 1. This is the heading for our table of results. We need a table of results. We need a table of values, which is going to give us the coordinates, which coordinates we are going to use to plot our graph, which graph we call a quadratic graph, and which graph we are supposed to use to solve the equations that have been given to us by the examiner. But we said a graph is supposed to be a smooth curve, which must be having either a maximum value or a minimum value, which we call a turning point. And we said the turning point is that point where a graph changes direction. Now, Mr. Examiner, sir, when we are drawing our table of results, we are going to make sure that the first value is x and the last value will be y. Then in between, that is what we are going to have written as the 2x minus 1 into x plus 3. But dear Mr. Examiner, sir, we also need to know that an equation, a quadratic equation, can either be given to you in a factorized form like this one, or in an expanded form like this. It can either be factorized in 2 brackets or it may be expanded. At times they might be meaning the same equation, so don't get confused. Now let us go ahead. In our table of results, Mr. Examiner, sir, I'm not going to use a ruler, but those out there, you are expected to use a ruler. Now, we said our first values must be values of x. But they are telling us x should start from, do we start from -5? Remember here, the inequality sign is only 1. -5 is less than x, which means x is greater than -5. Implying that if you have only one inequality symbol here like this, you don't start with a -5. You start from the next value, which is a -4. So we are going to have, Mr. Examiner, sir, a -4 there. And then from -4, we shall go to a -3. From -3, we go to a -2. -2, we shall go to a -1. But they said you go up to a +1. We are having 2 inequality symbols, so which means 1 is inclusive, but the -5 was exclusive. So from there we shall go to a 0. From 0 we continue up to a 1. Those are our values of x. But after writing the values of x, we are now going to get, what are we going to get? We are going to get the first bracket, which is a 2x minus a 1. And then the second bracket, which is an x plus 3. An x plus 3 there. So we have the 2x minus 1 in its own home. We have the x plus 3 in also its own home. But we said in our table of results, the values of x must come first. And then lastly, what do we have? The values of y. So we need another row here for the values of y. Mr. Examiner, sir, we are moving on well. Like that. It must be a closed table. Use your pencil, your sharp pencil, to draw your closed table. The table must be closed. Mr. Examiner, sir, I'm requesting for some pieces of chalk.